at Stratton, the medical publishing house that first published blood. This award honors two senior investigators whose contributions to hematology in both basic and clinical translational research are well recognized and have taken place over a period of several years. A list of past recipients is being displayed. The 2019 Henry M. Stratton Medal for Basic Research is presented to Dr. William Eaton of the National Institute of Diabetes and Digestive and Kidney Diseases of the National Institutes of Health. Dr. Eaton, an NIH Distinguished Investigator and Chief of the Laboratory of Chemical Physics at NIDDK, is being recognized for his pioneering work on biochemical and biophysical research on sickle cell disease pathophysiology and drug therapy. Notably, he described the sickle hemoglobin polymerization reaction that causes red cell sickling and delineated the protective effects of fetal hemoglobin. This work led to a better understanding of the idea that proper treatment can result from replacing a limited fraction of sickle hemoglobin with fetal hemoglobin. His research contributed to the development of hydroxyurea, an effective therapeutic agent for sickle cell disease that slows sickling of red cells by inducing fetal hemoglobin synthesis. Dr. Eaton's research group has also developed a sensitive test for measuring the time it takes for a blood cell to sickle, in hopes that being able to slow sickling will prevent complications such as blood vessel obstruction. His current research is focused on high-throughput screening of drug libraries with the aim of discovering inexpensive oral drugs for sickle cell disease that can be used worldwide, particularly in low-resource areas. Dr. Eaton?
It is truly a great honor for me to receive this award from the Society in recognition of my basic research on sickle hemoglobin polymerization. So I first want to say just a few words on how I got into sickle cell research. I was a bit of a maverick at Penn Medical School as one of its very first MD PhD students in the 1960s. My PhD thesis was on the electronic spectra of hemes in single protein crystals using a microspectrophotometer I built and their interpretation using quantum mechanics. But this work actually prepared me for my first studies related to sickle cell disease, which was on the spectra of single sickled cells in polarized light to obtain information on the orientation of the hemoglobin molecule in the sickle fiber. This study sparked my interest in trying to understand the mechanism of fiber formation using the methods of physical chemistry. Elucidating mechanism comes from kinetic studies, where I and my colleague Jim Hofrichter discovered a delay period or lag phase prior to the appearance of hemoglobin S fibers that's enormously sensitive to the sickle hemoglobin concentration, to the 30th power of the concentration. It remains today the most concentration-sensitive process known in all of science by far, and explains why even a modest dilution of fetal hemoglobin induced by hydroxyurea is primarily responsible for its therapeutic effectiveness. You might also be interested to know that with Frank Ferrone, Jim and I developed a novel nucleation mechanism in the 1980s to explain the remarkable sickle hemoglobin polymerization kinetics. This mechanism has been adopted by the leading basic researchers on Alzheimer's disease to explain the aggregation kinetics of the A-beta peptide. Finally, I should mention that whatever success I've had in applying my results on the thermodynamics and kinetics to sickle cell disease has been largely due to the guidance, advice, and encouragement of a great biochemist and an intellectual giant of hematology, H. Franklin Bunn. Frank was the very first hematologist to understand our physical chemistry findings and their relevance to sickle cell disease. So I thank Frank Bunn, as well as the American Society of Hematology, for this very prestigious award. Thank you.